So here we have a problem where we have to find a gravitational force between a hollowed sphere and a sphere with small mass. All the values is given. We have to find the gravitational force between those two spheres. One is hollowed, the other one is not hollowed. Okay, so how can we find it? There's a couple of ways of finding. So I think we can solve this problem in this way. We can, for instance, find the gravitational force between a solid sphere, okay, where we have, this is fully solid sphere, okay. Then we have a distance, everything. We have to find the gravitational force between them, F, okay. We have the gravitational force between this solid big sphere and small sphere, so I call it F1. Then we have to find a gravitational force between this hollowed sphere, so mass hollowed, and solid sphere. We have to find this force, and then after that we can just find the gravitational force, so I call this one F3, by just subtracting F1 minus F2, and that's it. Okay, so how can we find it then? First of all, let's find F1. So the F1 is very simple, where we have G, total mass, which is already given, 24 kg, then small mass, then divide by distance squared. Okay, you can calculate this one very easy. Now what about F2? The F2 is equal universal gravitational force, mass of the hollowed, mass of this guy, so this one, and divided by the distance will be what? Now the distance will be, since this is r over 2, and from here to here is a d, then the distance will be d plus r over 2 squared. Okay, now the question, how can we find the mass of the hollowed? That's a very good question. So mass of the hollowed is basically can be found by, we know that density is a constant, so rho is equal total mass without any hole divided by the volume, and which is this one is equal to also the mass of the hollowed, which is this guy, mass of the hollowed divided by the volume of the hollowed. Okay, so the mass of the hollowed, just keep it here. The volume of the hollowed is 4 over 3 pi r cube. Mass of the hollowed, let's keep it here. What is the volume of the hollowed? So it's 4 over 3 pi. The radius of the hollowed sphere is r over 2. And r over 2 power of 3, right? So this guy will cancel, also with the r will cancel. Then we can see that the total mass without any hole is equal to the 8 times of the mass of the hollowed. Okay, or in other words, we can say that mass of the hollowed is equal total mass divided by the 8 times. Okay, so that means we can say that it is equal to the G, mass of the hollowed is basically equal to the total mass divided by the 8 times, and that mass divided by the D plus r over 2 squared. So that's it. You have to find what is F2, and you have to find what is F1, and then you can subtract from each other. Okay, then you will get gravitational force between hollowed big sphere and between a small sphere of M. So that's it.